Hey guys, how's it going? So I found a new question that I thought I'd share with you about proving things. I am getting more and more used to proofs, and it's just taking what you know and applying it, like I've said several times. So here is a question. If XYZ forms a primitive Pythagorean triple, show that either X or Y is divisible by 3. So as we know, a primitive Pythagorean triple is three numbers that fits the equation in integers x squared plus y squared is equal to z squared, where x, y, and z are integers. So like for example, some examples are 3, 4, and 5, because 3 squared plus 4 squared is 25, which is 5 squared. Let me write example here. Another one is 5, 12, and 13. Another one is 7, 24, and 25. And one more, 15, 8, and 17. You can go verify for yourselves that these are primitive Pythagorean triples, kind of like, if you put these on a right triangle and then you have your x, y, and z, this is not drawn to scale. It would fit the triangle perfectly, essentially. So yeah, I'm just gonna erase this part. I'll keep the question. So as you know, the way like it's done is like x is equal to m squared minus n squared. Y is equal to 2mn, and z is equal to m squared plus n squared, where there are two conditions. First of all, m and n are positive integers, and m is not congruent to n mod 2, meaning that m and n don't have the same parity. Like, so one of them is even and one of them is odd. They cannot be both odd or even, or else it would contradict the fact that XYZ is a primitive Pythagorean triple. I'm not going to go into the details of that. You can verify that yourself. And feel free to watch some internet links on descriptions on like the proof of Pythagorean triples showing that X is Y and Z are in these forms. So let's get to it. So this is what we know. I'm not going to erase this. I was going to erase it, but I decided not to. Um, First of all, observe that y is always divisible by 4. And the reason why is because you have 2mn, because um, one of m or n is even. And if one of m or n is even, then you have a factor of 2 in the mn, and then 2 times 2 is 4. So you have a factor of 4 in your y. And notice earlier in the video, I provided a bunch of examples for the y value. They all were divisible by 4, all the y values in those examples I gave. So 4 divides y for that reason. So now 4 divides y, so therefore that means, this will be important later. Let's choose something that has a factor of 3. Y is congruent to either 0 mod 12, or y is congruent to plus or minus 4 mod 12. Plus or minus 4, because if it's not 0 mod 12, then it's congruent to 4 or 8 mod 12. Yeah. So if y is congruent to 0 mod 12, then we're done, basically, because that means 3 divides y, because if something's divisible by 12, then it's obviously divisible by 3, and 3 can't divide x, like x can't be divisible by 3, or else the GCD of x and y is not 1. It would be at least 3, which is a contradiction. So if 3 divides y, it cannot divide x. Now, if 3 does not divide y, or simply put, y is congruent to 4 or 8 mod 12, well, then there are a few possibilities. Let's assume for a second that 3 did not divide x, okay? If 3 does not divide x, then x would be congruent to 1, 5, 7, or 11 mod 12. So I'll do 1 plus or minus 1 plus or minus 5 mod 12. Okay, so we have that. Let me think. 1, 3, 5, 7, 9, 11. And x obviously can't be even since y is an even number here, since it's congruent to 12. Oh, I should have mentioned earlier. I'll mention it somewhere here. X is odd and y is even. I hope you guys can see why though, right? Because m and n don't have the same parity. So like, so then y is even here. And since m and n don't have the same parity, an odd number squared will be odd and an even number squared will be even. So yeah, x is odd and y is even. Yeah, I should have mentioned that earlier. Sorry, yeah. But I mean, it's even if I didn't mention it, you could have seen it for yourselves, right? Yeah, because 4 mod 12 is divisible by 2, and all these x congruences are odd, implies x is odd, right? So then, if there's 2 categories. If x is congruent to plus or minus 1 mod 12, then let's plug this congruency into the Pythagorean triple, seeing y is congruent. So then you have 1 squared plus 4 squared. Notice it doesn't matter plus or minus 4 for the squared. You'll get the same value. Is congruent to 17 because that's 1 plus 16 is 17, which is congruent to 5 mod 12. So then if x is congruent to plus or minus 1 mod 12, this implies that z squared, is congruent to 5 mod 12. But that's a contradiction because there's no possible z value that fits this congruency. It just doesn't work. So yeah, that's out of the picture. If x is congruent to plus or minus 5 mod 12, let's plug this into the Pythagorean triple. You get 5 squared plus 4 squared. That's congruent to 41. And that's also a congruent to 5 mod 12. So you have z squared is congruent to 5 mod 12. But again, that's not possible because there's no solution for z. So these don't form a primitive Pythagorean triple, meaning that x cannot be congruent to plus or minus 1 or plus or minus 5 mod 12 if y is congruent to plus or minus 4 mod 12, or 3 does not divide y. But if if 3 does divide x, or we could say x is congruent to plus or minus 3 mod 12, then what you have is something that looks like this. You have 3 plus or minus 3 squared plus 4 squared. Aha, that's congruent to 25. But 25 is congruent to 1 mod 12. And z squared congruent to 1 mod 12 has a solution. It's possible. It has a solution. I'm not going to discuss what solutions it has. You can easily do that with Chinese remainder theorem, but it works, right? So therefore, if conclusion, I'm running out of space here, but I don't really want to erase anything. If 3 divides, so like you see here, if y is divisible by 3, then x can't be divisible by 3. And if y is not divisible by 3, then x is divisible by 3. So we can conclude, hence, if xyz is a primitive Pythagorean triple, then either x is divisible by 3 or y is divisible by 3, where 3 divided, they're the both same way to put it. So that's all for this video. It's another way of applying what you know into proofs. I love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.